Welcome to the video. Today new topic for a special integration factor. What's the special integration factor method? We learn if the equation is exact differential equation, how to solve. If it is non-exact, if it is not exact, how we solve. We will use special integration factor. Of course, this method contains some condition. We said that equation will be not exact. What's the condition of exact? My equal nx. We said that it must be non-exact. So my does not equal nx. First of all, the equation is not exact. We will create new function as px or py. Px my minus nx over n. But what's the condition about px? This function must be depends on only x. If it's work, we can calculate integration factor, that is, we can use the special integration factor method. If it is not working, we will try to another alternative function for us, which is called py. If that function py depends on only y, we will say yes, we can use special integration factor and we will find integration factor as well. Px, if it is not working, try py. If one of them is working, we will say we can use special integration factor. If we have px, integration factor, exponential integral px dx. If py, exponential integral py dy. After finding integration factor, what's the important things here? We will multiply our differential equation by integration factor, and the equation that we obtain will be exact, and we know how to solve exact differential equation. Find the integration factor, multiply by differential equation and make it exact. Let's start. This is the coefficient of the x is m and the coefficient of dy is m. What is my? Derivative of m with respect to y, it will be here 2x squared. Are there any y? No. This is 0. Derivative of y with respect to y, 1. And the derivative of n with respect to x. Here x squared 2x. We keep other variable y. Minus x, derivative of a minus x with respect to x is minus 1. You see they are not equal. So equation is not exact. If it is not exact, we will try to find px and it must be only x. If it is not working, we will try py. Px my. What is my? It is 1 minus multiply the derivative of n with respect to x by minus. Here nx, let's multiply by minus 2xy minus plus 1 over n. What is n here? X squared y minus x. So it is equal to minus 2xy x squared y minus x. In this topic, if you want to obtain some function just depends on only x or just depends on only y, but it contains the theorem of xy, it means you must simplify something. How you can simplify something in mathematics? Of course, you should find common factor. If you find common factor, something in bracket, and then we can simplify by. So the important things you will ask yourself in these topics, can we find some common factors or not? Because if you find some common factors, maybe we can simplify and obtain just a function depends only x. So here 2 is or minus 2 is common factor. If minus 2 is common factor, we can write like that, or let's say just 2 1 minus xy here, and x is common factor for denominator, xy minus 1. You see 1 minus xy minus 1, we can simplify just it, we have minus 1 because they are opposite according to multiplication, okay, according to addition. That's why minus 1 minus xy minus 1, so minus 1. So it's equal px equal minus 2 over x. You see we just have only x. For example, you took common factor, something like that, but still px doesn't depend on only x. You will try py. Okay, so we calculate px. It depends on only x. Let's find integration factor. Integration factor exponential px dx. So it is exponential px minus 2 over x dx. Exponential minus 2. What's the integral of 1 over x? Integral of 1 over x, we know that this is ln x. So what we have here, the important things in mathematics, if you have base and logarithmic function like this, e ln g of x, ln and e remove each other, we have g of x. This is rule. Okay, but be careful, the coefficient of logarithmic function must be 1. You cannot remove in this form e ln remove. No, the coefficient of logarithmic function must be 1. So the other property that we have, if we have coefficient in logarithmic function, coefficient goes inside s power. So ln x to the power of a. So first things, make the coefficient of logarithmic function by using this property 1. So minus 2 will go s power. So it will be e ln x to the power of minus 2. Now you can remove, because the coefficient of logarithmic function 1, remove this one, x to the power of minus 2. We calculate integration factor. You see, here you cannot remove and write minus 2x. This is important. You have to make the coefficient 1 by using this property. So we calculate what is the rest. We will multiply differential equation by integration factor. So multiply x minus 2 times our differential equation, 2x square plus y dx plus x square y minus x dy equal to 0. So it will be x minus 2 x square 2. Here y times x minus 2 dx. Here y x square x minus 2 y x to the power of minus 2 x to the power of minus y dy. So this is exact differential equation. This is exact differential equation. Let's continue. Let's check if it is exact or not. This is m, this is n. So derivative of m with respect to y. With respect to y, here this is constant 0. With respect to y, derivative of 1, y equal 1 times x to the power of minus 2, x to the power of minus 2. Derivative of n with respect to x. Here, no x, derivative 0. Derivative of x here, put minus 1 in front of x, minus 1 will be plus. Decrease the power, minus 1, minus 2. You see they are equal, so this is exact. What the technique says for the exact differential equation, we know that take integral for both sides separately. The integral of first part, the integral of this part, 2 constant 2x. The integral of this part, increase the power, x to the power of minus 1 over minus 1. Let's put minus here and will be like that. X to the power of minus 1 over minus 1, and here I put minus 1. So integral of second part, y minus x to the power of minus 1 dy. So y with respect to y, it will be y square over 2. Y square over 2. So x to the power of minus 1. Here there is no y, that's why this is constant. What's the integral of constant? Itself times variable minus x to the power of minus 1 times y. Don't forget to integral of constant itself times variable. So what the technique says for exact, write the first integral 2x minus y x to the power of minus 1, and write the second one. But as we write second one, ask yourself if we have same expression or not before. Y square over 2, did we use it before? No, we must write minus x minus 1 times y. Here we have that part, so we must cancel it, and it's finished, equalize to c. So this is our solution of differential equation by using special integration factor. Everything will be same about these topics, no difference, just the important things for us. If px is not working, that is just not depends on only x, try py, and integration factor will be with respect to y. This is the just difference for any type question that we have.